Welcome to the deep dive. Today we're zeroing in on a piece of technology that might seem a bit unassuming at first, but it's often the last line of defense in some really high-stakes environments. We're talking about advanced liquid detection. Specifically, we're getting into the nitty-gritty of the NTI E-TLD-P100. It's a tape-style liquid detector. Our mission today is really for you to understand the critical engineering choices that make a simple sensor into, well, truly reliable hardware. I mean, when you think about the cost of water damage in a data center, it's millions of dollars lost in minutes. This tape is the answer. So let's unpack it.
Right, and what's fascinating here is defining what this thing is actually looking for. Its main job, of course, is to detect water, to warn you about a flood. But, and this is the key thing, it's engineered specifically for conductive liquids.
Hold on. If it only detects conductive liquids, doesn't that limit its use? Like, what if you have a leak of something else, say dielectric cooling fluid?
That's exactly the point. It's specialization. In a data center, your biggest worry is a water leak, from a cooling system or maybe a burst pipe. By focusing only on conductive fluids, so water, it's designed to just ignore all the other stuff.
Like oils or solvents.
Exactly. That choice radically reduces false positives. It means when that alarm goes off, you know it's the real threat.
Okay, that makes sense. And I guess the construction reflects that. It's a self-adhesive tape with copper fiber electrodes.
Right, and they're protected by this durable netted cover.
It sounds simple, but why copper fiber? What's the thinking there?
Well, copper's a great conductor, obviously. But that netting, it does more than just protect it. It actually ensures that even a tiny amount of liquid gets drawn across the electrodes. It's capillary action.
Okay.
But the real genius here isn't just the detection, it's the reliability. The system has a continuous tape integrity self-check.
Why is that self-check so important?
Because a huge percentage of sensor failures are just simple mechanical ones. A cable gets cut, or the tape gets damaged before a leak ever happens. This self-check ensures your investment isn't just sitting there dead. For a facility that needs constant uptime, knowing your sensor is online is half the battle.
Let's pause on that because the sensitivity claim here is just extraordinary. It says the minimum puddle it can detect is 0.125 inches. That's only 3 millimeters. Is that just marketing hype? I mean, in the real world, how reliable is that?
It's totally reliable, and it's because of the physics we just mentioned. That netted cover guarantees the capillary action will bridge the gap. I've seen situations where a tiny pinhole leak, the kind that makes a 3 millimeter puddle, shorts out an entire battery backup system.
Right.
So that precision is the only way you catch those slow creeping kinds of leaks.
And that really dictates where you'd use this.
Yeah.
We're talking serious infrastructure protection.
Yes, exactly. This isn't some desktop gadget. You're mounting it on the floor or running it under pipes in a raised floor.
It has a weather-resistant enclosure,
And operationally, it draws about 60 milliamps at 12 volts DC.
which sounds technical, but why is that relevant for, someone setting this up?
It's relevant because that 12-volt requirement means it integrates right into existing monitoring systems like the NTI E2D or 5D. You don't need a separate power supply.
And you can scale it. The tape itself comes in different lengths, 10 feet, 25, all the way up to 100 feet.
Right. And if you connect this to the bigger picture of, say, enterprise risk management, you see the investment. The 100-foot powered model is about $2,560. But the package also includes a 2-year warranty. And this is huge for some. It's TAA compliant.
So it meets federal procurement standards.
Yes, that proves its supply chain integrity, which is a massive deal for government or high-security facilities.
So wrapping this up, the key takeaway for you is that this kind of early warning is built on two things. First, detecting the leak with incredible precision. And second, that continuous self-check to make sure the detector is actually working 24/7.
And that leads to a final thought for you to consider. If sophisticated monitoring now requires detection down to a tiny 3 millimeter puddle, what does that say about the hidden vulnerabilities in your own critical environments, the ones we all tend to overlook? Thinking about that might just change how you approach risk management entirely.